Hello, Handmade Seattle. My name is Ilia and I like making things. Here is my technical demo. Some time ago, I stumbled upon this guy on Twitter, who posts a lot of threads, and looked interesting to me. Then I noticed that these threads link to other threads, that link to more threads, and it's a whole network of threads. But it was hard to explore using the official apps without getting lost. So over several months, I built my own web app that makes it easier to explore this network as a graph. It looks just like Twitter. You can scroll around. It opens outgoing links side by side. It supports incoming links as well. You can go multiple levels deep without losing context. It has a gallery view for photos and a button that teleports you to a random place in the network. So far it looks like a regular web app, but there is one more twist to it. If we open DevTools, we see that it's actually a full-screen WebGL canvas. And if we look at the files that were loaded, the entire app is written in C++ and compiled to WebAssembly, which allows it to take tens of kilobytes instead of megabytes of JavaScript that Twitter would send to you. The megabytes are spent on the data we actually care about. This file is a data blob that contains the entire network of 2,000 threads, 18,000 tweets, and as much text as War and Peace novel. After it's loaded, everything is in memory, and clicking on things is fast. Now I'd like to give you a quick look at how C++, WebAssembly, and WebGL make things different for the developer, compared to the regular web dev. Let's start with data format. On the web, you would usually go with JSON. For our case, there are users, there are tweets, they reference each other. To get it ready, the browser needs to parse the JSON and allocate many small JavaScript objects, one for every string, user, and tweet. In WebAssembly, we got linear memory, so it's easy to work with binary data. We start with a blob. Some of it is text, some of it is pointers. It is loaded at some memory address by the browser. To get it ready for use, we only need to know which parts of it are pointers, and loop through them to add the base address. This one loop is all that's required to get our data structures set up. When it comes to layout, web uses the box model. In HTML, we define rectangles, which contain child rectangles, and so on down the tree. To space them apart, we add CSS margins, padding, and some flexbox. If the browser doesn't do what we want, we go read some more on how CSS works and try again. In vis-a-vis, it's plain arithmetic. We start at some x and y, and just add numbers to put everything in the exact place. Sometimes we divide numbers, but not very often. Now let's render things. On the web, rendering is magic. We give boxes to the browser, it somehow puts them on the screen, nobody really knows how it works. In vis-a-vis, we use WebGL shaders, one for every type of primitive that we need. Glyph atlas and some geometry gives us text, then we draw icons, user pics, photos, and finally frame the photos. Actually, I lied about the web. If we look at what the browser is doing behind the curtain, it's very similar. It also has glyph atlas, icon atlas, images, and rounded rectangles, all calling their own shaders. They're even using the same APIs to do that. So we're basically re-implementing a part of a browser for more control. This was a quick look at vis-a-vis and some of its internals. You can check it out at vis-a-vis GitHub.io. If you'd like to get in touch, you can message me here in the chat or on Twitter at @ilidemi, and here is my email as well. I live in Seattle and would be happy to meet more folks in the area.
Right. Question from Mark. Have I shown it to Visa? I have. He said it's cool. If I handle text rendering myself, do I have any plans for accessibility? This is not a goal. This is a small side project. I don't know how possible this is technically. I've read that there is something called Shadow DOM, which is like you would create similar type of structure in the backend to the browser, and then browser would do accessibility through it. I do not have experience with it. Question, does it only do the one thread? I do not understand that question. You can try to ask it again. How long did it take to make? So this was 6 months full-time effort, but that included reverse engineering Twitter UI's data schema, which has like thousands of fields or something like that. So I needed to pick out only like the data that actually ends up on the screen. That included like grabbing the data in like tons of requests and like building the pipeline that compiles it to this big blob. And there is reproducing the like visual design as well and experimenting with the layout. So it's not just like requirements and go implement the requirements. How much would Twitter need to offer me to sell it to them? I'm planning to put this on GitHub, so I don't know if they would want to buy it, but I would appreciate if they wanted to buy it. Does it constantly render the screen like a normal game loop, or is it more event-based? It is event-based. It kind of helps that it still has to integrate with the browser, so the events are coming are like DOM events, so I can like do work on updating data structures, mark a Boolean to like re-render the next frame, and then I think, yes, there is a loop, but then it checks that Boolean and then it like does nothing if there is no change. Zoom in out feature eventually. The zoom works even right now on a desktop with keyboard Control minus Control plus. The like more precise zoom, maybe I didn't get to it yet. What other UI layouts did I try before ending up at current left to right column design? So the left right column design was like the easiest thing to implement. I tried to brainstorm, like, is there some layout that would work for like the entire network at once? I did not find a good one yet, but like it would involve two-dimensional things somehow. Question from Jacob Bell. Does it support Unicode? If so, how did they implement it? So it does support Unicode. There are some emojis in there. There are some like non-latent scripts. Unicode, in terms of text rendering, is it doesn't do any fancy grapheme cluster analysis. It works on code points. And for every code point, I just ask the browser to render a character like on a canvas. Then I capture it as a texture and then use it as just like the WebGL textures. And then for the like memory representation, it's white chars from C++. Do I currently support playing videos and Twitter posts? I do not support any sort of animation. So for videos and GIFs, like I do show the first frame exactly as like Twitter would do it. And then for every tweet, if you click on it, it will actually open like the Twitter itself and a new tab if you want to like interact with it or maybe see the conversation. Shift scroll wheel scrolls horizontally. Is it browser or is it me? Yes, it is me because horizontal scrolling is important here. And also like you can scroll with the mouse with like right click and drag. Does my system handle real-time updates, real-time additions to the graph? If no, any idea of how I would approach this? So right now, like the whole website is static. So like everything is statically compiled, lives on the CDN. So like update would be me rerunning the whole thing and like uploading different files. On the front end, like real-time things, this would probably be like WebSockets, so probably more JavaScript or like more talking with WebAssembly. I do not know exactly.
All right, so we'll do a round of applause for Ilia.
Yep.
Vis-a-vis. I saw more typing, but we must go on with the show. You may ping Ilia later in the casual chat or send him a DM for any further questions. Thank you so much.